Hi everyone. Today I will be going over my design choices and implementation of the checklist application. So starting off from the front end, one of the core features of a checklist is that it can have many different categories. So to take advantage of React's selective rendering, I made sure that each component had its own unique key. That way, when you're editing one category, such as changing its name or adding a file, the other categories will not have to be re-rendered. What this does is it allows performance improvements, especially if the categories get quite large in number. On the front end as well, I added robust error handling. For example, if the user makes a bad input, such as a empty string as a category name, or they want to extract a list that doesn't exist in the database, they will get warnings saying that they can't do that. Now moving on to the database in the back end, all the checklists are stored within these three tables. So checklists, files, and categories. Now the beauty of this structure is that although there are many different categories tied to a single checklist ID, by using a foreign key and reference statement, you can cross-reference them and see exactly which categories are tied to each checklist. And the same principle is true for cross-referencing files to their parent categories here with this foreign statement. By doing it this way, as soon as you have a checklist ID, you can basically reconstruct the entire checklist by cascading down, first finding the categories and then finding the files associated with those categories. Now, when editing a checklist, what I have the program do right now is it erases the checklist completely and rewrites it from scratch from the front-end input. It's slightly inefficient because you don't need to replace everything. There's probably only a few changes in each edit, but my implementation is more robust in that although you're losing some efficiency, you're less prone to errors by, you have to figure out exactly what has changed and what has been kept constant if you're selectively updating specific fields. But there can definitely be more optimizations in that front. So one of the other limitations of the app is if you have multiple users trying to edit a single checklist. Due to the fact that there's a complete rewrite every time a edit happens in the back end, if two people are editing, the person who pushes the changes last will actually overwrite everything the person who pushed first did. One way to combat this is to lock down the editing privileges as soon as one person starts making an edit and only release it when they have pushed their changes to the database. Another way to combat this is to have all the changes reflect immediately in every single user's GUI as soon as a change is made. So on to scaling. One way to increase the number of users that can use the app is to have multiple instances of the server and also have a load balancer. This kind of solves two problems. One is that if one server goes down due to internal error or bad inputs, at least you have other servers to support the application and database. And having a load balancer will distribute traffic so that every single server can be within its capacity to serve users. Now, further considerations. One is that both the third-party URLs and the creating data checklist GUI, they're visible to the public. So without an authentication service, it's easy for bad actors to input data or read data they're not supposed to. So implementing an authentication service or logging exactly who is putting what into the database can help combat bad actors and see that the right people are accessing the database. Well, that concludes the presentation. Thank you for watching.